Okay, so let me now talk about join. As you know, a join is a method of linking data between one or more tables based on values of the common columns between the tables. There are different kinds of syntax that can be used when you are trying to join two or more tables. For example, there is a syntax like join on syntax, so which is express a join when the tables have no common attribute names and the query returns only rows that meet the indicated join condition. And typically the syntax is select column list from table 1, join table 2 on join condition. And you can also use common attribute names to join tables. And most common use of duplicate column names is the existence of a foreign key, which means that when you are, suppose you are joining two tables, so there is a primary key and foreign key relationship between those two tables, and you join those two tables using the primary key foreign key relationship. As you know, there are different kinds of joins. So let me first talk about inner joins, and MySQL supports inner joins as well as outer joins, and also it supports natural joins. So inner joins return only rows from the tables that match on a common value, and outer joins return the same matched rows as the inner join plus unmatched rows from one table or the other. And natural join returns all rows with matching values in the matching columns and eliminates duplicate columns. It determines the common attributes by looking for attributes with identical names and compatible data types. It only selects the rows with common values in the common attributes. If there are no common attributes, it returns the relational product of the two tables. And here is the syntax. Select column list from table 1, natural join, table 2. Now I'm going to give you an example using join. So again, we are using the same database as we used earlier. So in this example, I'm going to show you how to list all customers who ordered a clock hammer. Okay, so in order to execute this query, we have to first look at the database model. What we are trying to find is, we are trying to find the customers who ordered a product called claw hammer. Now, if you look at the database model, you will notice that the customer table is connected with the invoice table, and the invoice table is also connected with the line table, and the line table is connected with the product table. Because if you try to find out the customer name just looking at the product table, you won't be able to find the customer name, because the customer name does not exist in the product table, which means you need to join here 4 tables. First, you need to join the customer table with the invoice table, and then you have to join the invoice table with the line table, and then you have to join the line table with the product table. So that means there are 4 tables involved in order to find the desired results. So now let's construct the query. Okay, so let me explain how I constructed the query. As I said, there are 4 tables involved in this query: the customer table, the invoice table, the line table, and the product table. So first, we are selecting customer code, customer last name, customer first name, and also we need the product code and product description from customer table, invoice table, line table, and product table, where look at the join condition, customer.customer code equals invoice.customer code, because this is how these two tables, customer table and invoice table, are connected by the primary key foreign key relationship using the common attribute customer code. Similarly, if you look at the invoice table and the line table, you will notice that invoice.invoice number equals line.invoice number. So these are the common attributes between the invoice table and line table, invoice number. And the common attribute between line table and the product table is p underscore code. So line.pcode equals product.pcode, and then I write product description equals clawhammer. So this is how I constructed the query, and let me run this query. And when I run this query, I get the result. So it gave me the desired result. So these are the two customers who actually ordered clawhammer. Okay, now I'm going to show you the same query can be written in a different syntax using join. So look at this. Select distinct customer code, customer underscore last name, customer underscore first name from customer, join invoice on customer code equals invoice.customer code, join line on invoice.invoice number equals line.invoice number, join product on product.pcode equals line underscore pcode, where p underscore descript equals clawhammer. I wanted to show you that a different syntax, using a different syntax, you can also write the same query. And let me run the query and you will see that I also got the same result. Okay, now let us look at another query. In this query, we are going to find all customers who purchase products with product code 13-Q2/P2 or 23109-HB. Now, in order to find all customers who purchase these products, first let us look at the database model. Okay, now let us explain how we construct this query. We already know what the product code is. So what we are going to do is we are going to join the invoice table and the line table. And we already know that there is a common attribute between this invoice table and line table, which is invoice number. So we join these two tables, and also we know what the product code is. We are going to use that product code to find the customer code that is present in invoice table, and then using those conditions, we are going to find the customer code and use that customer code to find out the names of the customers from the customer table. So that's what we are going to do. So now let us look at the query. So there are two queries. There is one inner query and there is an outer query. And first let's look at the inner query. Select distinct customer code from line invoice, where line.invoice number and equals invoice.invoice number and p code in. So these are the two product codes, 13-Q2/P2 and 23109-HB. So once we join these two tables, line and invoice, and they have their common attribute invoice number, we are going to get the customer code. And after we get the customer code, we use that customer code to get the customer name from the customer table and use that. And then look at this. So the outer query is select customer.customer code, customer.customer last name from customer, where customer.customer code in, and this customer code in comes from the after you run the inner query. So let's run the query first. Once we run this query, we are going to get the output. So there are 4 customers who purchase those two products. Now what we are going to do is, now I'm going to show you that the same query can be written in a different way, and I'm going to show you another way of writing the same query. So what I'm doing here is I am writing joining here. Actually I'm joining 3 tables, customer, invoice and line, where customer.customer code equals invoice.customer code and invoice.invoice number equals invoice dot line dot invoice number, and product code uh, in and I write those names of those two products codes 13-Q2/P2 and 23109 HB. And then what I'm doing is after I get the results, I group by customer code. So let us run this query and you will also get the same results here. So what I did is I showed you that the same query can be written in two different ways and both of them will give you the same results. Another thing I would like to mention is I've used this word distinct here before the customer code. Uh, the reason is there may be duplicate customer code. So in order to avoid duplicate customer code, I use the word distinct here. Also in the second query also, I also used the word distinct for the same reason, to avoid duplicate customer code.